All right, welcome to Blue Pen Land again. Uh, let's look at this thing. This is a gravity problem, right? So it's going to use the gravitational field formula where G is the opposite of the change in gravitational potential over the distance. And it also might use G as F over M. That's the sort of thing that we're doing here, right? Okay, so a gravitational field exerts a force of 140 newtons on a 17 kilogram mass away from B toward point A. Well, this is gravity, right? So A must be, if it's toward point A must be on the bottom and B is on the top, right? And here's this mass, and it's exerting a force toward A but away from B, right? Okay, so let's see, okay. And we can use this equation to figure out the strength of the field. So let's do that. G is F over M is equal to 140 newtons divided by 17 kilograms is equal to, hold on here, hold the presses, 140, this is division, this is tough stuff, divided by 17, this is 8.235, and that's newtons per kilogram, and it's down, right? So if we were making up positive, we'd make that negative. Okay. What is the change in gravitational potential if you go from B to A? All right, so let's figure this out. The change in gravitational potential, right? So now we're doing, it's tough. Okay, so we're doing this thing, right? Okay, so G is equal to the opposite of the change in potential over the change in displacement, right? Okay. So if I go from B to A, right, 45 meters, this is 45 meters. If I go from B to A, I'm going this way, right? So that's 45 meters down, right? Okay, and then my G is also down. So let's make down negative. This is the negative direction. This is the positive direction. I'm trying to get the right sign here is what I'm going to try to do. And then I'll argue through it another way. Okay, but let's do it mathematically, right? So G is negative 8.2353 newtons per kilogram. I made it negative because in my convention it's toward A, and A is in the negative direction, the way I drew it here, right? Okay, because this is gravity, this is pretty straightforward, okay. Then that's equal to the opposite of the answer we're trying to get, right? Over the displacement. So the displacement is down 45 meters, right? So minus 45 meters, right? We go from B to A. So B to A is down 45. That's why I'm making it negative. All right. So now I've got that. I'm going to multiply by 45. And now I've got the answer of 370.588. And that's the opposite of the change in potential. So the change in potential is negative 370.588. Okay? Is negative 371, and that is joules per kilogram. All right, good enough. Now let's do it the other way, right? Let's look at the change in potential. Let's just sort of reason through it using common sense, right? If we're going toward the direction that the thing wants to go, there's a force in the direction we're going. That is, we're going down, and the force is down. Then we are doing negative work on the mass, right? It's actually giving us energy, right? So the change in potential would be a negative change in potential because we're doing negative work on it, right? Did I say charge? Mass. All right. And then the other reasoning is that we're just simply lowering it 45 meters. So by common sense, we're decreasing its potential. Raising up a mass is increasing the potential. All right.